Good evening, my 12th standard warriors and all the dropper students. It's time to study the dispersion of light and prisms in the Pathfinder series with me, Shreyas, your physics master teacher at Vedantu, and I'm going live. Welcome all the students who are live, and even if you're watching it recorded, I hope you're going to have an amazing time in this session. So, what is this session all about? Well, today we are doing the next lecture of ray optics, the 12th standard Pathfinder series, where you get full-fledged lectures on all the 12th standard topics. I have already done term 1 and term 2 syllabus is nearing the end. So in today's class, we are going to see the geometry of the prism, the parameters associated with the prism, then we are going to go to the minimum deviation, the graphs, and then we'll go to also thin prisms, and then dispersion, and then combination of prisms. That's what we are going to do in today's session. Welcome Darshan, hi Kalai, hello Niranjan, Aishwarya, thank you for all the hearts, thank you Darshan for the heart, hello Gaji, thank you so much my lovely warriors. And here I am, your capto, your navigator, your guide, your mentor for physics on this channel. And I have been mentoring, guiding students for more than a decade now, and many of my students under my mentorship and under my teaching have gone into the top-notch institutes in the country, and I take pride in it. And I am really hopeful that you too are going to make me proud this year too. And yes, if you want daily doses of knowledge bits, quizzes, and some fun facts, and also want to check and stalk my profile, here is where you can do that, and that's Shreyas_Vedantu, my Instagram handle. Well, here I have the first question for all of you. Hello Tabu, good evening. Hi Ankit, nice to see you back. Hi Sulavendan. Hello Kopu. Hello Wood. Hello Subramanyam. Welcome aboard. Hello Rudra Gauris. Hello Saurdeep Mathi. Hello Niranjan. Welcome everyone. Yes, I was there in the V Pro session at 4:15. Oh, you too were there, Aishwarya. It was so nice to interact with all the 11th standard students out there. It was real fun, and I could see many of you could also recognize me. Thank you so much. Have you taken the third dose? No, Ankit, not yet. I'm not even eligible right now. If I get eligible, definitely I'll take it. All right, the booster dose. Okay, Kalai saying B. Hello Shiva. Vana Veera Raghava Rao saying A. Wow, really, high five Aishwarya. And I think I'll be seeing you guys a little bit more often, especially the 11th to 12th moving students. And yes, for the 12th standard students, there is a surprise plan coming in on vPro for all of you. Stay tuned, you will see what it is. Thank you Gopu so much. Ankit saying B. Well, students are confused between white and black. I'll tell you what. See, have you seen the picture of a moon? Have you guys seen the picture of or rather from the moon, where Neil Armstrong and all of them, they click photographs? Have you seen how the atmosphere on the moon looks like? It looks black. There is no atmosphere on the moon. Reason why the atmosphere on Earth looks blue or orange depending on the time of the day is because of the scattering of light. So the scattering of light is what makes the sky colored. Without atmosphere, there is no scattering, there is no backdrop, there is no screen, there is nothing onto which the light is falling. The light is just falling onto the surface of the Earth. So there is no reference, there is nothing on which the light can scatter. So absolutely black, that's what you will get. Yep, that's the answer. Very good. And looks like Ankit has seen all the phases of the moon. Rudra, it is not white. White will be when all the light gets scattered equally. But unfortunately, the light does not get scattered equally. It depends on the wavelength, and blue light being scattered the most, you see it bluish in color. All right, I hope this is fine and this is clear. Hi Surya. Hello. Oh my God, Tushar, trust me, Omicron is generally not so serious. Even I was suffering from Omicron. Some cases become severe. I know you are not vaccinated or probably just one dose, but trust me, have faith, nothing will go wrong. Just keep it light, keep it mild, and don't think about it. In fact, if you're suffering from something, you should keep your mind away by solving problems. That way you will not think about what you're suffering from. So in fact, you should solve more problems. When you get tired, take a rest, take sleep, and drink a lot of fluids. And obviously follow whatever doctor's prescription is there. Just do that. Don't worry, you'll be fine. No problem, Aishwarya. See you. Take care. Hello, D. Pratibha. Hi, Surya. Hi, Blessy. I am very good. So I hope you have smashed the like button. In case you haven't, please do that right now. And I hope you guys have also hit the subscribe button so that you get all the lectures in English medium for 11th, for 12th, till the end of JEE, till the end of VidSat, till the end of CET, till the end of JEE Advanced, everything. So all for you. Go ahead, hit the like and the subscribe button. And let me also remind you that last year we had 1,500 plus students who cracked JEE Advanced from Vedantu alone, which is more than 6%, which is entering into IITs. We had thousands of students who had got amazing percentiles, about 90 percentile in JEE Mains. So many students cracking VidSat, so many students acing board examinations. All of this was possible because of the right guidance, right mentorship, and all these students from Vedantu enjoyed the courses at Vedantu and also have followed the timetables, the strategies, the assignments, the test series, and have analyzed the tests time to time, and that's why they have excelled in their studies. So if you are not yet part of the revolution, the online digital revolution, and you want to crack JEE sitting at home, go ahead, check out the link which is there in the description box below. And there is a Republic Day sale going on. Usual offers 10%, but this time it's 50% because of Republic Day. I'm pretty sure you don't want to miss it. And if you have missed the few classes, don't worry, the replays are available for all of you. All right. So having said that, I hope that I'll be seeing you very soon in the JEE crash course for JEE 2022. And if you are 11th, I'll be seeing you probably in the 11th to 12th moving batches as well. Having said that, now let's move to the geometry of a prism. All right, are you guys ready? Okay. Hello, Harsha. Hello, Kondipalli. Welcome. Okay, YT has more distractions. Well, I'll probably post something. I should do something about how to not get distracted from YT. That's a very good important point. Let me see if I can find the research material. And in fact, I had downloaded some extensions and all of that. I will definitely tell you guys about it. Hello, Siddharth. Hello, unknown. Now, in a prism, by the way, first of all, what is a prism? Okay, basically any two surfaces which are at an angle is nothing but a prism. It need not look triangular. Light should enter from one surface, refract, enter the next surface, refract. In a glass slab, the surfaces are parallel, so the light does not deviate. The light will not deviate in a glass slab, it only has a lateral shift. Do you remember that? But in a prism, the surfaces are not parallel, they are at an angle. That is nothing but a prism. So it could be of any shape, it's just that you should have two surfaces which are not parallel. So things like this, imagine this. This is one surface, this is something else, this is something else, and this is something else. If the light comes in from here, refracts and refracts, this is also a prism. What matters to us is the angle of prism, sometimes also called as the refracting angle. Don't get confused with the names. So it is that angle between those two surfaces where the light is getting refracted. That means all you need to do is extend these surfaces and see what angle it makes. This is called as the angle of the prism. This is called as the angle of the prism. As simple as that. In most of the books, the prism looks like this. But remember, if this part is not there, or if this part is curved or some haphazard shape, it really doesn't matter, because all that matters is this surface and this surface where the light is going to get refracted. Is that clear? Have you developed a new idea of a prism? How many of you did not know this? How many of you did not know this? Yep, many of you thought prism should look triangular, right? But now you know prism may not look triangular. What matters is just that the sides should be not parallel and make some angle A over there. So I'll just start marking the angles right over here. Okay, let me just start marking the angles. 1 second. Okay, there we go. this over here, okay, this over here, I'm just going to call it A. And what is A? A is called as the angle of the prism. Angle of the prism. Now, when light rays enter, thermo is 11th standard topic that was done yesterday. So every alternate day we have 11th and 12th standard syllabus. Now, let's say the light enters from here. Okay, light enters from here, and let's say it gets refracted somewhere here, and then again it refracts over here. It's going from dense to rare, so it should bend away from the normal, something like this. So this is the journey of the ray of light. I'm just showing some random angles. Please don't think they are equilateral or they are 60 degrees. It looks like equilateral, but it need not be equilateral. Mind it. Okay, let's start marking all the what is that, normals and all of that. So here it is. So this is one normal which I can mark right over here, and this is another normal which I can mark right over here. What am I interested? I am interested in figuring out what are these different angles called. I will give you that. Number 2, we'll talk about the relationship between these angles. Number 2, okay. Number 3, we are also going to talk about the deviation of this ray of light. Why deviation? Because the ray of light was actually technically going here. Because of this prism, it has now got bent. Okay, it has now moved to some other angle. So we are going to talk about the deviation also. I hope this is fine. Thank you, Blessed Joseph, so much. Now let's start marking the angles like I mentioned before. First, the angle at which the light enters in with respect to the normal on the first surface, that is usually labeled as I1. What is it called? I1. And this I1 is often also called as the angle of incidence. Angle of incidence. This angle by which it comes out over here is often labeled as I2. Some books also label it as small e. That I2 or small e stands for the angle of emergence. Angle of emergence. Now, please remember, if I reverse the direction of light, by reversibility principle, we know I2 will become incident and I1 will become emergent. Agreed? So by reversibility, I2 can be also incident, I1 will become emergent. So that's the reason why we have used the symbols I and not something else, so that there is no confusion whatsoever. I hope this is clear. Yes, Rudra, I'm going to make threshold frequency lecture in modern physics. Don't worry. Okay, definitely, Nanda Kumar. I will plan for something, definitely. In fact, I just conducted a motivation session just few days back on Republic Day, Coffee with Shreyas sir. So I hope you are there. But yes, more sessions will come up. Don't worry. Next angle that you need to know about, and that is, one over here. Okay, one over here. This I'm going to call it as R1, and this over here I'm going to call it as R2. These are your inside angles after refraction. So R1 and R2 are the angles inside the prism after the light rays get refracted, or here it is before the refraction. So that's it. Okay, fair enough. I hope everybody has understood what these angles are. Now I have a feeling these angles are somehow related to each other, and let's see what it could be. Observe this particular triangle. I'll tell you which triangle. Just one second. Let me just highlight this for you. Okay, just look at this triangle. The one over here, which I'm highlighting. Okay, the one over here. Look at this. Can you see this triangle? In this triangle, I have a feeling if I add the angles, I might be able to find some kind of a relationship. Observe now. Okay, just observe. So, in that triangle, if I add the angles, that means angle A plus, what is this angle? Think this total angle is 90 because it is the normal. This is R1, so 90 minus R1, correct? So that angle is nothing but 90 minus R1 plus, look at this angle over here. This line over here is 90 degrees, okay? And this is R2, so how much is this remaining part? This is 90, this is R2, so how much is this remaining part? Obviously 90 minus R2. Can you see that, my warriors? So this is 90 minus R2. What is the sum of the angles of a triangle. It is 180 degrees. 90 plus 90, 90 plus 90 over here is 180. So minus R1 minus R2 is over here, and this is 180 degrees. Now you can see 180, 180 gets cancelled. So if it cancels, shift R1 and R2 on the other side. So A will be equal to R1 plus R2. This is one beautiful relationship which we have got. The angle of the prism is the sum of the internal angles of refraction of that prism. I hope this is clear. I hope this is clear. Fair enough. Kalai, remember there are some students who are probably studying from the scratch or studying from the basics. So I need to explain everything. Okay. So hold on, and also be considerate to those students who probably might take some time to understand. All right. I have to think about the average person as well. Now, the next thing that you need to remember is the angle of deviation. How do I calculate the angle of deviation? Observe this now. So for that, what I'm going to do is, look at this. Over here, the light deviates by some angle. The light deviates by some angle, and I can see that very easily right over here. Okay, it deviates by some angle. Let's say delta 1. This is the angle of deviation here. Okay, you can see that. Okay, and as soon as it goes here, again it deviates by certain angle. Let's say delta 2. It deviates by delta 1 and then deviates by delta 2. So the total deviation, the total deviation, which is delta, will be delta 1 plus delta 2. And what is delta 1? Everybody knows this. For refracting rays at a surface, the deviation is incident minus refracted, or refracted minus incident. I hope this is clear. Yes, this is for JEE term 2, Priya. Thank you, Narayan Dutt. Thank you. All right. Yes, Narayan, you can cover optics in 1.5 week, not exactly 1 week, but 1.5 week. Yes. In fact, you can watch all my classes. This is almost like the second last or third last class. All right. No problem. EGL Sangram, watch the replay. Now, delta 1 is nothing but, look at this. Delta 1 will be this angle, which is I1 minus R1. So it will be nothing but I1 minus R1. I hope you guys see that. That's the standard formula. Same way, delta 2 will be big minus that small angle, I2 minus R2. So it will be nothing but I2 minus R2. I hope you can see that. Again, the same formula which you have learned back in refraction. Angle of deviation is incidence minus refraction, the modulus of that. Here I know I is more than R. That's why I comes first, R comes later on. Now this will be I1, take I2 from there, and here R1 and R2 are together. So R1 plus R2 is together. I have taken the minus sign common. Now what is R1 plus R2? I just got it here. R1 plus R2 is A. Therefore, what will I get? Delta is nothing but I1 plus I2 minus A. So this is another important relationship which every student must know. Thank you so much, Rakesh. All right, is that clear? So these are the two important formulas which every student must know. I have put it up for all of you in the printed form also, in case you don't like my handwriting. So don't worry, it's there. What is these angles and all of that? I have also mentioned all the angles, the deviation, etc. in the printed form as well. Yes, Jagdish, I have taught refraction through curved surface. It's there in the playlist as well, and in the past videos just done last week. You can find it very easily. Okay, just go to the videos, you will get it. Okay, so I have given you all these angles, angle of deviation, I1, I2 and A. Let's start with a question. Let's start with a question coming up on your screen. Thank you, Blessy. Sir, have KVPI dates come? No, not yet, Priya. If it comes, definitely I will announce it. Okay, don't worry. For now, let's prepare for JEE. Automatically, we'll prepare for KVPI. Okay, Tushar, I think the expected date for NEET 2022 would be somewhere in June, okay, or May end, somewhere around that. Here is the question. What angle should a ray of light be incident on the face of a prism of a refracting angle 60 degrees so that it suffers total internal reflection? Interesting. At the other side, refractive index is root of 7/3. This root was there on the entire thing. Maybe it is not so obvious, but let me make it very obvious. Okay, so let's start doing this question. But before that, we need to visualize what is happening. The light is incident on one face and just getting totally internal reflected on the second face. Just when it is about to get totally internally reflected, what is the angle of refraction on the other side, on the rarer side? It is 90 degrees almost. Everybody remembers this? I'm very good, Jai Ajinkya. Nice to see you back. So, shouldn't the light ray be like almost coming out 90 when it is just about to be totally internally reflected? TIR, total internal reflection. And continuing with the normals over here. So the normal drawn over here will probably look something like this. And obviously this ray will probably come something like this. This would be your R2. Remember, this is 90. So basically I2 is 90 degrees. Got it? And again drawing more normals right over here. Okay, so this is another normal right over here. Perfecto. And there we go. This is nothing but your R1. And finally, this is nothing but your I1. And this over here is angle of the prism. Let's try and solve this question. Okay. And remember, this one over here is your second surface. This one over here is the first surface. Let's start with second surface first, because I have more information over here. The question demands us to find what is the angle of incidence. That means I1 is asked. To find I1, I need to know R1. To know R1, I need to find R2, because I know R1 and R2 are related. To find R2, I need to start solving for the second surface first. I hope this is clear. All right. Waves के बिना wave optics नहीं पढ़ा सकते क्या? पढ़ा सकता हूँ, but if you don't have any idea, then you will find a lot of difficulty. Okay. Anyways, let's start with this. So for the second surface, what do we get, guys? Observe this carefully. I can say that the sine of this angle upon the sine of this angle will be the refractive index, rare to dense. You can think of it that way. So sine of 90 divided by sine of R2 is nothing but mu. Okay, and mu is nothing but root of 7 by 3. So sine 90 is 1. So basically sine of R2, therefore sine of R2 is nothing but root of 3 by 7. That's what I got. I got R2. Now I need to find R1. How do I find that out? Observe. I just know that A is equal to R1 plus R2. Therefore, R1 will be A minus R2. But R2, I don't think I know this perfectly, because it is not a standard angle. Because it is not a standard angle, I will make use of trigonometry, and that's the best part about the problem. How you can apply maths in physics and solve the question. And the best part is that you're going to find some probably easy looking final answer, hopefully. Let's try this out. How do I find this? Well, simple. Take sine on both sides. Take sine on both sides. So sine of R1, you could also take cos, it really doesn't matter, is equal to sine of A minus R2. Now, do I know the formula for sine of A minus B? Hell, I do. Sine of A minus B is sine A cos B minus cos A sine B, right? Standard addition subtraction formulas. So sine of R1 will be sine of A into cos of R2 minus cos of A into sine of R2. Let's see what happens next. Therefore, sine of R1 will be sine A. Acha, is the A given? Yes, A angle is clearly mentioned to be 60 degrees right over here. Sine 60. How much is sine 60? It is root 3 divided by 2. Cos. Oh, I don't know cos. I just know the sine. But I know what I can do. The value of sine can give me the value of cos as well. Remember, cos R2 will be 1 minus sine square R2. This is from the trigonometric identity. Sine square plus cos square is 1. Correct? Hello Ankita, good evening. All right. My calculus was pretty strong, Narayana. If you don't like calculus, then you will find it difficult to study not just maths but also physics. So calculus should be decently, at least above average, it should be decent enough. Maybe not the strongest, but decent enough it should be if you want to crack JEE. So this will be equal to 1 minus square of this, that means 3 by 7. 7 minus 3 is 4, root of 4. 7 minus 3 is 4, root of 4, 2. So 2 by root 7. So that is what cos of R2 is. I am going to take this value of cos of R by 2, R2, okay, over here, and I'm going to substitute it. And let's see what do I get. So it is 2 by root 7 minus cos A. Cos 60 is nothing but half into sin R2. I know it from here. Sin R2 is root of 3 by 7. Now 2 gets cancelled, correct? So that's all root of 3 by 7 over here. Root of 3 by 7 is also over here. So 1 minus half. 1 minus half is half. So this will be nothing but half of root of 3 by 7. So that's your sine of R1. Good. Fair enough. So I've got R1, but that's not the final task. The task is to find I1, find the angle of incidence. So the last part will be to solve it for surface number 1. And let's see what do we get. So for surface 1, this is incident, this is refracted. Use Snell's law. So sine of I1 divided by sine of R1 will be mu. So therefore, sine of I1 will be mu. Mu is given. It is nothing but root of 7 by 3. Sine of R1, if you take it there, so it will be nothing but half of root of 3 by 7. Root of 7 by 3, root of 3 by 7. Don't they cancel? If they cancel, what is remaining? Only half is remaining. So only if half is remaining, that implies what is the value of I1, my warriors? What is the value of I1? Shouldn't I1 be 30 degrees? And that's your final answer. Beautiful question. Yogananda, whenever the dates come, I will definitely let you know. So what has just happened is that we have used Snell's law, total internal reflection, and then also the geometrical aspect, and then the trigonometry over here. So this is a brilliant JEE Advanced type of question. I hope this is clear. Jagdish, I am doing it, bacha. So don't worry if your syllabus is not complete. I have given you by Valentine's Day. We'll be doing it, and once you are done with the syllabus with me, trust me, you will have enough time for revision, and then you can start, with your full syllabus tests also. Meanwhile, continue your other subjects revision and even physics revision. Just follow my lectures. Trust me, you will do it properly. You will get that confidence. Okay. So moving on to the next one. Yes, 30 degrees is the answer. Now, you have understood from the previous question that if I change this, this will change. If this is changing, this will change. This changes, that changes. And the deviation will also change. So, if you try this out experimentally, you take a prism, you make the light incident at different angles, you will find that at one particular angle, the deviation is the least. And that is a special case in which you get very good questions, and you have to remember the final outcome and the formula and what is the entire graph and other aspects around it. So we want to know when does the light deviate, it bends the least for different angles of incidence. I have many options, so out of that only one angle will give the least angle of incidence. Now imagine this, if, okay, let me just draw normally over here and here, for example, and let's say this is our light rays. Go like this, and like this. This is R2, this is R2, and this is I2. Okay, this is I2. Let's write this as I2, and this is R1, and this is I1. This is I1, and obviously this is A. Now you will see that the light ray has clearly deviated by some angle. This is the delta. This is the total angle of deviation, like you can see. And if you draw a graph, of delta versus different angles of incidence, you can do this practically. Okay, you will find that the graph comes out to be somewhat like this. That clearly shows that there is some delta, which is the least delta, delta minimum, for some angle of incidence. For certain angle of incidence, the delta is the least. Okay. Now let's try to analyze this problem little bit differently and observe this. Okay. We all know that, delta is I1 plus I2 minus A. Okay, delta is I1 plus I2 minus A. I1 is incident, this is incident, and I2 is nothing but emergent angle. Now look at the graph carefully, you will understand one unique thing. Look at this. Say, if I take some angle of incidence, I1 over here, let's say this point, I get some value of delta over here. Do you see that? I get some value of delta over there. But that same delta, I get it for some other angle of incidence also. Do you see that? If for some angle of incidence I get some delta, I get the same delta for some other angle of incidence. Do you see that there are two angles for which I get the same delta? Do you guys see that there are two angles? I'll mark this over here. These are the two incident angles for the same delta, correct? But there is a catch when delta is minimum. When delta is minimum, there is only one angle because there are no two roots. It's like the roots of an equation, something like that. Do you observe that? Can you see that carefully? It's like the two roots of some equation. But here you can see there is only one root or one solution or only one angle for which you get delta minimum. Okay, what could this mean? Okay, here is how I interpret it. Imagine, observe this blue line. If this is the angle of incidence for which I get this delta, the other angle of incidence for which I get the same delta, shouldn't that be I2? I'll tell you why. Because of reversibility principle of light. See, if for some angle I1, I get some delta, if I reverse the direction of light, then this I2 will become incident and it will again have the same deviation the other way around. Understood? That means what are the two values over here that you are getting? One is I1, one is I2. One is I1, one is I2. Did you observe that? Did you see that? Understood, my warriors? The x-axis, if you want, I will just make it, okay, just one second. Okay, the x-axis, if you want, I'll just call this as incident angle rather than calling it as I1. Okay, so I'm just going to call it as, one second, incident angle. So when the delta is same, usually you get, okay, I will observe this, when delta is same, you get two different angles for which you get the same delta. And how did I arrive at that conclusion? Again, I'll explain. See, if this I1 is the incident angle, then you get some deviation over here. If I1 is the incident angle, you get the some delta over here. Now, if you reverse the direction of light, you still get the same delta. You still will get the same delta. That time, what will be the angle of incidence? I2 will be the angle of incidence. So, you get the same delta for I1 and I2. Is that now clear? Got it? Yes. Thank you, Nick, for all the love. Little confusing, tricky. But once you get it, you get it. That's it. You just have to think a little bit carefully. So, Jai Ajinkya, I hope this is clear. Observe this. So, for this angle and this angle, I will get the same delta. It's just reverse the direction of light. Okay, just reverse the direction of light. That's it. If you reverse the direction of light, think light is coming like this. This will be the incident angle. Again, I will get the same delta, but delta might not be seen here. You will get the delta over here. It will deviate by the same amount, but it's the same delta. So, two angles give you same delta. But at delta minimum, you only get it for one angle. That means when you are over here, when you are at delta minimum, can I not say I1 is equal to I2? can I not say I1 is equal to I2? Got it? So for delta minimum, that's the reason why the incident and the emergent angles are equal. Incident and emergent angles are equal. Now if I1 is equal to I2, what else will happen? It will also imply R1 is equal to R2. R1 will be equal to R2. Can you see that? Difference between normal and perpendicular, it means the same thing, Jayant Bhatti. Same, normal, perpendicular, 90 degrees, it's all orthogonal, means the same thing. And this line, green line, will be parallel to the base. This green line and the base will be parallel because these two angles are similar, equal. So it becomes an isosceles triangle. This is also an isosceles triangle. The small triangle and the big triangle are similar to each other. So the base are parallel. I hope this is clear. Yes, Abhishek, it is. Now, next part. Once you got this concept, you can also find the value of delta. Observe this. Delta will be, since both of them are equal, so I1 plus I1 minus A. Therefore, 2 times of I1 will be nothing but delta plus A. Therefore, I1 will be equal to delta plus A divided by 2. This is what is the value of I1. And since R1 is equal to R2, from here, what else do I get? From here, what else do I get? Think about it. Remember, R1 and R2 together give you A, right? So therefore, 2 times of R1 will be A because both of them are equal. So therefore, R1 will be just A by 2. So I have found out R1, I have found out I1. Probably there is a reason why I just did that. And the reason why I just did that is because I can apply Snell's law and find some amazing relationship. So observe this. By Snell's law, what do I get? By Snell's law, I'll get sine of I1 divided by sine of I2 will be refractive index. Sine of I1 by, sine of I1 by sine of R1. Sine of I1 by sine of R1 will be the refractive index, correct? So let's substitute that. What is sine of I1? It is this whole value. So it will be sine of delta plus A divided by 2 divided by sine of R1. What is sine of R1? It will be sine of A by 2. This will be equal to mu. Now this is a very, very important relationship. But this delta is not any ordinary delta. This delta is actually speaking delta minimum. This is delta minimum because I have equated I1 and I2. So that's why this is delta minimum. Very important relationship. I hope this is understood. Crystal clear? Yes, semiconductors and communication I will definitely be teaching, bacha. Definitely. Thank you, Abhishek. Okay, so I have put this up for all of you. So at minimum deviation, the I1 and I2s are equal. So angle of incidence is angle of emergence. The ray becomes parallel to the base. R1 also becomes R2. And the graph looks something like this. For all other deltas, you get 2 different angles. But at minimum deviation, it's one unique angle where I1 is equal to I2. And mu is given by sine of A plus delta minimum by 2 upon sine of A by 2. A is the angle of prism, of course. So let's solve some questions. I'm not sure if you can see this very clearly, but yep, let's solve this. And here I will probably mark the rays in case you're not able to see it. The ray goes like this, ray goes like this. Okay, this is the direction. Then it goes like this and it continues its journey over here and then it comes out. A, B and C. You can see this is A, this is B and this is C. 3 prisms are there. Out of these 3 prisms, only I think 1 or 2 or 3 maybe have minimum deviation. Which prisms do you think have minimum deviation? That's the question. Can we call the graph as a parabola? Yes, it turns out to be a parabola. Yep. So when you derive it, it turns out to be a parabola. All right, let's see guys. What do you guys say? Out of this prisms A, B and C, which prisms do you think minimum deviation is occurring? Remember, I had given you the condition for minimum deviation. It's symmetric. There is symmetry in it. If there is symmetry, the ray inside, the ray inside is parallel to the base of the prism. Base of the prism, right? The ray inside is parallel to the base of the prism. I hope you remember that. So the moment you have this prism, the ray is parallel. This and this, they should be parallel to each other. So look at the prisms, and I think you can see it very, very clearly now. Which prisms have minimum deviation? I can clearly see this ray and this base. Look at this prism, prism A. This and this are parallel. Can you see that? These two are parallel lines. Similarly, I can also notice this line and this line parallel, because this is the base of the triangle. The apex is over here. Can you see that? This and these lines are parallel, but something which is not parallel maybe is this, because this is not parallel to this. Can you see that? Obviously, this and this are not parallel. They are at an angle. So, which prisms have minimum deviation? Is it not obvious now? A and B, of course. No, C, you can see the lines are not parallel. Okay, this is incident, this is emergent. So this should be parallel to this base. This is the base, this is the apex angle. So it's definitely not parallel, and that's why it is not minimum deviation. I hope this is understood. Okay, very tricky question, but a good question. Next one coming up on your screen now. So what do we have over here? We have angle of minimum deviation is equal to the angle of prism A of an equilateral glass prism, the angle of incidence at which the minimum deviation will be obtained as how much? Okay, let's try to figure this out. Do I have a diagram? Maybe no, but let's try to draw it and see what do we get. Okay, let's see. Here we have a prism. Oops. Okay, 1 second. Okay, so there we go. Here we have a prism, and it is an equilateral prism. That means this angle is 60 degrees. Perfect. And the angle of incidence at which the minimum deviation will be obtained. Okay, but the angle of minimum deviation is equal to the angle of prism. By this statement, it just says that delta is equal to A, which is nothing but equal to 60 degrees. That's all. That's the first piece of information. Next piece of information. Since it is minimum, since the word minimum is used, what does that word minimum mention or imply? It means I1 is equal to I2, R1 is equal to R2. Perfect? Great. Question is the angle of incidence at which minimum deviation will be obtained. Well, I think I know which formula I should use. Remember this formula? Delta is I1 plus I2 minus A. I know the value of delta. I know the value of A. I know I1 and I2 are also equal, so probably it will help. So delta is 60. I1 and I2 both are equal, so 2 times of I1. A is nothing but 60. So 2I1 will be 60 plus 60, which is 120 degrees. So I1 is just 60 degrees. So that's the value of I1. And is it not what has been asked? What is the angle of incidence? So that should be 60 degrees. I hope this is clear. Hello Gaji, Shruti. Yes, Abhishek, the option A is correct, bacha. Very good, very good. Who all have answered correctly? Very good, Sudhakar. The stream started Vishwa Srinivas probably at 40 minutes back or something. Yes, yeah, it's 7:40 now, so 40 minutes back around. Okay, fair enough. Let's move on to the next one coming up on your screen. Okay, so this one is done, right? Yep, this one is done. So moving on, there is a prism of refractive index √2 and refracting angle A, and it produces minimum deviation of a ray which is falling on one face at incident angle 45. The value of A in degree is very, very good question. Thank you so much, Gaji Shruti. It means a lot. Okay, so what do we do now? Let's try to figure out what and all is given to us, and then we'll proceed ahead. So here we go. This is our prism. The prism of refractive index is given. Refracting angle A is given. Okay, and the rays of light which enter, they produce some minimum deviation delta M Fair enough. Of a ray on one face at an angle of incidence 45. This is important. This angle over here is given to be 45 degrees. This I1 is given to be 45 degrees. But is it minimum deviation? Yes. It's also mentioned it is minimum deviation. Fair enough. So if it is minimum deviation, I1 will be equal to I2, which will be equal to 45 degrees. I1 will be equal to I2, which is equal to 45 degrees. But the question says, what is the value of A? Now, how do I find out A? I think for finding out A, the only way I can do it is by finding out R1 and R2. But since it is minimum deviation, I know R1 is equal to R2. So I can just say 2R1. This is since R1 is equal to R2. That means what do I need? I just need R1. What do I need? I just need R1. Now, how do I find R1? Look at the given pieces of information. The prism has a refractive index of √2. I think now you know what to do. Yes, make use of Snell's law. Make use of Snell's law. You should be getting the answer. If you use Snell's law, you will get sine of I1 by sine of R1 is mu. Correct? Incident and refracted sines ratio, you should get the refractive index. Sine I1, I think I know sine I1, that is sine of 45, and mu comes below, mu is nothing but √2, is equal to sine of R1. Therefore, sine of R1 will be sine 45, that's 1 by √2, 1 by √2 by √2, which is nothing but 1 by 2. Whose sine is half? Sine 30. So therefore, R1 is nothing but 30 degrees. The moment I get R1, I know what to do next. Just put the value over there. So it will be 2 times of 30 degrees, which is 60 degrees. So that's your final answer. What are you noticing in all these questions? Isn't it just an extension of Snell's law, geometry, trigonometry? If you are good at geometry, trigonometry, that's it. You will find ray optics easy. And at the start of ray optics, I also mentioned many books call this chapter as geometrical optics. Reason? There is a lot of theorems, properties, triangles, squares, circles, tangents, all of those are used, and simultaneously you need knowledge of trigonometry. Without that, you will definitely not do well in ray optics. Let me warn you. So, yeah, develop the liking towards trigonometry and geometry if you want to excel in ray optics, that is. Alright, let's move on to the next question. Vishwa, total internal reflection is a part of refraction at plane surface. I have conducted another class just few days back. You can find it in my past playlist and past videos. Just watch the refraction at plane surface. In that I have derived all those formulas and given you all those things for total internal reflection. Sandeep is wowed. That's something what I like. Yes, you should always be wowed by problems, by solutions, by derivations and the values. It should excite you. Abhishek, thermo is over. Thermo is over. That was the last class. Second law. We have done heat transfer, everything. So now we need to go to waves in 11th standard. Alright. So what is a thin prism? Simply put, a thin prism is nothing but a prism whose angle at the apex, the angle of prism is very small. 5 degrees, 10 degrees, etc. Yes, Sandeep, they will ask derivation in boards. If you have noticed the sample paper of 12th term 2, there were so many derivations which were there. Yep. Now, you can see this prism is very narrow, thin, the angle is very small. So all the other angles will be small. Now what many institutions and many channels won't tell you is this. Observe carefully. Okay. I hope nothing is going to come up anywhere else. Okay, the angle is small and all right, all these things. Fair enough. Now observe this. Remember, I just gave you a chart of deviation with angle of incidence. I just gave it to you. And if this is delta and if this is incidence angle, I told you that the graph looks U-shaped for normal prisms, but for thin prisms, the graph just becomes like this. Yes, the graph flattens almost, and almost all the deltas are same, there is no distinction between delta minimum and delta. So if this is your delta minimum and this is where I1 is equal to I2, all the other deltas are roughly the same. So it's flattened. So this is only for thin prism. Is only for thin prism. For thick prism or for prisms which are having good angle, the graph becomes highly U-shaped, it becomes curved. So there are different deltas for different angles. So that enables us to find delta as a general formula, not just specifically for deviation when it is minimum. In general deviation, I can find it out. So I can very easily mention in general, delta is approximately delta minimum. Do you guys agree with this statement? There is no difference between delta at any different angle of incidence and delta minimum. Everybody agrees. Please put up a thumbs up in the chat box. All right. So now, do you also remember I just gave you one formula which said mu is equal to sine of A plus a delta minimum by 2 upon sine of A by 2. Now, since the prism angle is small, can I not say sine of A is roughly equal to A? That is the small angle approximation. So if I do that, and delta is also small, the deviation is also small, so therefore sine of delta is also approximately delta. Sine of A plus delta by 2 will also be small, so it will be also A plus delta by 2. So this will be nothing but A plus delta minimum by 2 upon A by 2. 2 cancels, delta minimum is roughly delta, so this will just become A plus delta divided by A. That's what I get. Now shift A over here and let A plus delta remain there as it is. So mu into A will become A plus delta, and therefore you will get delta is equal to A into mu minus 1. Now this is a very, very important relationship which I am blocking over here. The deviation in general for thin prisms is A into mu minus 1. A into mu minus 1. If you remember, that's it. You will be able to solve all the questions on dispersive power, dispersion angle, combination of prisms and all of that. As simple as that. So A into mu minus 1, but A should be small. Now I have a question for you. Should A be in radians or should it be in degrees? Should A be in radians or should A be in degrees? Let's see how many of you can answer this correctly. Think carefully. It's not what you think it is. Let's see how many of you can get this answer. Should A be in radians or should it be in degrees? Come on, my warriors, figure this out. What do you think? Meanwhile, let me just have some sip of water. Or it doesn't matter. Does it matter or does it not matter? Degrees, radian, okay. Think. I'll tell you what, it really doesn't matter. Okay, reason is, if you have to use this approximation, actually speaking, the angle should be in radians. Let's say you convert the numerator into radians, obviously you have to convert the denominator also in the radians. When you do the conversion here, convert into radians, won't the conversion factor cancel out? So, strictly speaking, if it cancels out and it's a ratio, it really doesn't matter whether you write A in degrees or in radians. So it works for both. It works for both. Keep this in mind. So this is something which should be there in your notes. And these kind of questions can come in JEE Advanced, BITSAT, you never know. So let's solve a question based on this. A light ray is passing through a thin prism of angle of prism 8 degrees. Find the refractive index of the prism if the angle of deviation is 2 degrees. The keyword is it's a thin prism. That's the keyword. It's a thin prism. And the moment the prism is thin, we know delta is nothing but A into mu minus 1. Is the deviation given? Yes, the deviation is 2 degrees. Is the angle of prism mentioned? Yes, it is mentioned as 8 degrees. Is mu given? That's what we have been asked. So into mu minus 1. So mu minus 1 will be 2 by 8, which is 1 by 4. So mu will be 1 plus 1 by 4. So it is nothing but 5 by 4. So is 5 by 4 there somewhere? Yes, it is there right over here. 5 by 4 is 1.25. That's it. For large angles, Manikandan, the graph looks somewhat like this. So let me just draw it over here. So this is delta versus the angle of incidence. So when the angle of prism is large, the graph will look something like this. So this is for large values. But if the prism is thin, then the graph looks like this. So the delta value is same. No matter where you go, the value of delta is same for all the angles of incidence. So that is how it differs. I hope that is understood, Mani. Okay, perfecto. Very good. Let's move on to the next one. Okay, this is an interesting question. A prism having an apex angle of 4 degrees is, and also refractive index is mentioned, is in front of a vertical plane mirror. Okay, right. As shown, through what total angle does the ray get deviated after reflection from the mirror? That's the question. Let's figure this out. Okay, so first of all, I hope you agree that if the light ray continued its journey without the prism, it will just go hit the mirror at normal incidence. It will go hit the mirror at normal incidence, correct? It will hit it normally. Only because of the prism, what's happening? The light ray is getting deviated, and you are seeing that it gets refracted, and it hits over here, and probably this is your angle at which it hits. Now, once it hits the mirror, obviously it's going to get reflected like that, and this will be also equal to that angle, because laws of reflection, right? So the question is, by how much did the ray deviate by? Okay, first I want you to understand what is the deviation looking like over here on the picture, on the diagram. Observe, the light ray was going like this, like that, on that green path. Finally, it ended up going like this. So don't you see, this is your delta, this was your incident, this was your final ray. So if I had to mark that delta over here, I would mark it over here like this. This is your delta. See if you are able to visualize this. This is your delta. And the reason why I'm marking that as the delta is because this green line will be parallel to this green line over here. So the light rays were going like that. It has turned by this much amount. Everybody agrees to this? Perfect. So let's try to find out what these angles are, and you will get the answer. Remember, it's a thin prism, so the light ray will deviate by some angle. It will deviate by some angle. So if I call this angle as I, this will be also I, and this will be also I. And deviation in a thin prism, what is it? It is A into mu minus 1. What is that deviation? It is I. What is A? I think it is mentioned, 4 degrees. Is mu given? Yes, 1.5. So 1.5 minus 1. So 1.5 minus 1, that's 0.5. 4 into 0.5, that's 2 degrees. So that is value of I. But I don't want the value of I want the value of delta. So what will be delta? Look at this. This is basically your I. What will be delta, guys? Delta will be 180 minus, not 2I, just I, be careful about it. So that will be 180 minus 2, which is 178 degrees. Is it there somewhere? Yes. Many people mark 176, which is wrong. 178 degrees. So Gaji, what has happened? Observe. The light ray was going like this. It was going and falling on the mirror perpendicular. In the prism, it got deviated. Thin prism. How much was the deviation? A into mu minus 1. A is given, mu is also given. So from that I got deviation is 2 degrees. So it deviated by 2 degrees. When it hits on the mirror, it will get reflected. By simple geometry, you know, since this line and this line are parallel, this angle and this angle are equal. These two are equal. And by reflection laws, these two angles are equal. That's it. So now, once I know this and this, both are 2 degrees. All the three are 2 degrees. So how much did it deviate by? It deviated by 180 minus I. 180 minus that, that's 178. I hope that is fine. Oh, fighter gaming. Your name only says fighters. So why you should be worried? Obviously, you have a lot of time. You can crack it. But follow my lectures, follow my strategies, follow my advices. Whatever classes you have missed, watch it all. It's all there on YouTube. Why you should worry? Watch it. Make a timetable, make a strategy, put up your goal on your desk, on your table, and study every day religiously for 6 to 7 hours. Remove all the distractions, cut out from your friends a little bit who are not so serious. Remove all the random social media apps. Trust me, you can do it. Okay, my God, Dakshin, I hope you do well, and please take care of yourself because things are not good around, and please stay safe, Bacha Dakshin. Okay, and I'm so glad that you still watch the replay. It shows your dedication. I'm so happy about it. Very good, Dakshin. It shows your spirit. Keep it up, Bacha. Hello, Magindaran Guru, join in. And yep, the answer is 178 degrees. Ready for some dispersion? Ready for some dispersion, my warriors? All right. So let's see what it is. Okay. What do you think dispersion is? Okay. Who can tell me the definition of dispersion? What is dispersion? Come on. The animation, the simulation right over here should be able to tell you what dispersion is all about. Dispersion is nothing but the separation of the colors or the spreading of colors because the refractive index is different for different colors. Spreading of light. Spreading of light is different from scattering of light. Scattering is different, spreading is different. Scattering is not because of refraction, it's because of multiple reflections and all of that. Whereas, due to refraction, what happens is different colors have different refractive indices. That's why the light spreads. Different colors will refract by different angles. And there are so many beautiful phenomena that occur because of refraction being different for different colors. The most famous example being the rainbow. Here, the droplets of water act like a prism because all you need is two surfaces. That's it. Remember, what is prism? Just two surfaces at an angle. And it so happens that the rays of light which enter into the drop, they get refracted, totally internally reflected and all of that. And because of it, you will see each color will refract by different angles and you see a beautiful rainbow. The white color is split into its constituent colors. Something like this. Like when you throw white light, it splits into its constituent colors. You can call it violet, indigo, blue, green, yellow, orange, red. That's your VIBGYOR. Violet, V, violet, indigo, blue, VIBGYOR, violet, indigo, blue, green, yellow, orange, red. That's something which you should know. And if there are more colors, that can be also spread, but these are your visible colors which are seen. And what happens is exactly the same in case of droplets. You can see the rays of light from the sun are actually white. Sun is actually white. Okay, it has all the colors. There are obviously ultraviolet, infrared also. Stray radiations are obviously there. And when it gets refracted, you will see that the person standing here feels that the colors are separated, coming from different places, and that's why you see the beautiful rainbow out there. Yep. By the way, I'm not sure how many of you know this, you can also see a secondary rainbow. Yep, you can also see a secondary rainbow, and that is, you know, a little bit fainter, but that happens because of two internal reflections and all of that. But yes, even that can happen. How many of you have seen two rainbows together? Two rainbows. And how many of you have seen the rainbow from an aeroplane or something? You know, as you go up, you can see more of that arc. And if you wondered, sir, I can see the rainbow there, so if I run towards the rainbow, will I be able to catch it? Will the rainbow fall somewhere on the ground, just like they show in some songs and in movies? That's not going to happen. As you move farther, the rainbow also will shift farther. It's a virtual image. It just makes a fool out of you. Well, you should be lucky enough to see a dual rainbow. And you should definitely think why you get dual rainbows. How will the ray diagram look like when two rainbows are formed together. Some of you have already seen like Samyukta and Magadharan. Very good, Rohit. Interesting, interesting. So yes, so as you go up, you will start seeing the circle. In fact, recently in Bangalore, just happened last year in 2021, I was just in a meeting and I have a picture of it as well on my phone. Maybe I should post it somewhere. And what I saw when I looked up in the sky was a circular rainbow. Yes, there was a rainbow which was formed just around the sun. It was like a halo and it looked beautiful. So many people went mad. Everybody just came out of the office and their schools and colleges and their homes. They were like, oh my God, a complete circular rainbow. That was beautiful. Okay, I'll probably post the picture maybe on our Telegram channel, so you can probably join it or follow me on my Instagram. Maybe I'll post it as my story. All right. So moving ahead, angular dispersion and power. Now what is angular dispersion? I just told you that each color spreads by different amount. Okay, I just showed it to you over here. Each color will spread to you by different amount. The angle of spread, how much does it spread by? This angle is called as angular dispersion. Angular dispersion. The angle by which it spreads is called as the angular dispersion. Okay, so let me just put it over here. So the angle subtended between the extreme rays, violet and red, you can see that, violet and red. So this is the violet and the red, all right, is called as the angular dispersion. Now the simplest way to look at angular dispersion is as follows. Observe this. This is your prism, okay, and the violet ray, probably if it is going like this, this is how the violet ray will look like. And if I continue this, this will be your delta of violet. This will be your delta of violet. Similarly for red, the red rays which are going like this, it will bend but little bit less. It will continue its journey like that. This will be your delta of red. Now you can see these are the two extreme rays. This angle between them is basically called as the dispersion angle, and the symbol for dispersion angle, sometimes people use delta theta, delta omega, whatever you want to call it. So I can call it delta theta, okay, doesn't matter. Okay, this is your dispersion angle, and you can clearly see delta theta is nothing but delta violet minus delta of red. Do you see that? The whole angle minus this angle will give you this remainder angle. Now, I hope this is clear. Yeah, Raghav, if you're in 12th and you want to join the crash course, yeah, please join it ASAP. The offer will go in just 2 days. Join it. Even if whatever you have missed, you can watch the replays of it. Join the batch which just started recently. That's fine. You'll get all the test series, everything. You'll not miss anything. Let me assure you on that. Okay, go ahead, join in, because right now it's on offer, 8,000 rupees. Again, it will increase to 9,000 rupees in just 2 days. Don't waste your 2 days now. Okay, let's start writing these values. Delta violet. Delta, we know what is it? Delta A into mu minus 1. So angle of prism into mu for the violet color minus 1. That's your delta. Minus A into delta of red minus 1. What will you get? Just think about it. A and A will get cancelled. What will be remaining? A into mu V. Oops, I made a mistake. I'm so sorry. This was not supposed to be delta. This was supposed to be mu. So sorry, guys. A into mu of red minus 1. Now, if you just operate on this, you are going to see A and A is going to get cancelled. So A into mu V, A into mu R. So what are you going to get? You're going to get A into mu V minus mu R. That's the formula that you're going to get. Sure, Raghav, you can ask me. You can ping me on my Instagram or leave a comment after the video ends. Definitely, I will interact with you, Raghav. Hello, Umesh, join in. Is that clear, my warriors? How you got this formula? This is the angular dispersion. Now, the next concept is dispersive power. It spreads, but how much does it spread per unit average deviation? Per unit average deviation. That is called as the dispersive power. Usually the symbol for that is omega. Now, what does this omega stand for? Observe this. It is nothing but how much does the light spread by delta theta upon the deviation of the average color. The average color of the rainbow is yellow, visible light is yellow, violet is extreme, red is extreme, the average is yellow. So it's the deviation of the average color. Basically, it is delta of yellow. Why? That's what omega is. And now, if you put all these values, you will get the answer. It's very simple to get it. Del theta, I just got it over there. It was A into mu V minus mu R. Okay, what is this mu V and mu R? Refractive index for violet, refractive index for red. I just told you it's different for different colors. Upon A, what is the formula for delta? A into mu minus 1. So A into mu for yellow minus 1. A gets cancelled, and I think you should get this. Mu V minus mu R upon mu yellow minus 1. Okay, mu yellow minus 1. Is that clear? I hope this is understood. So the point over here is that you don't have to remember these final formulas. That's why I'm not even blocking them. Just remember the definition. What is del theta? Del theta, or this angular dispersion, is the spread. So it will be the most extreme color minus the least extreme color. That angle between them is delta theta. Omega is the dispersion angle per unit average deviation. If you're wondering where this yellow color is, that yellow color will be somewhere in between. Okay, that yellow color will be somewhere in between them. So I'm not even showing that, but this will be your delta of yellow. Okay, per unit average deviation. That's it. Umesh, right now, trust me, every time I reply to some Instagram message, there is always a reply to that, and my inbox has just got full. I'll try to respond. I don't know how I'm going to manage. I need an assistant now. Please, somebody assist me. Okay, Raghav and Umesh, I'll try and respond to all of you, bacha log. Hello, Ganesh. Let's solve some questions on this based on the spread of the angle, the dispersive power, and all of that. Here is your first question. A monochromatic light is passed through a prism. Which color shows the minimum deviation? Come on, if you have been very observant and you have seen the slides carefully, you know what is the answer. So, if you are a 2022 aspirant and you have not done much of questions practice, first of all, pick up all the assignments, the books, PYQs, start solving ASAP. Do till mains level. The basic questions and the mains level questions, you need to pick it up ASAP, and you need to see some teacher solving these questions. That's very important. If you just probably sit on your own, you will get stuck somewhere. You will not feel that confident. So maybe you have lost the habit of solving questions. So you need to see lecture by lecture, at least unit by unit, you know how the questions are solved, and then get a hang of it, and then you will move on to the difficult questions. So learn the applications and then move to PYQ, and then you can go to advanced. All right. Yes, the correct answer is red, not violet. Some of you said red, violet also. That's wrong, guys. Look at this. I just showed you over here. The color which is least deviated is red. Violet has the most or highest refractive index, so highest deviation also. It's always ulta, okay? Violet, indigo blue, green, yellow, orange, red. Red is the least, violet is the most. Okay, that's how you should remember it. Next question. Okay, there we go. The dispersive power if the refractive indices of the material of the prism are this and this. Interesting question. Dispersive power. I just told you what is dispersive power. It is del theta by del of mean color, yellow color. Del theta, I just mentioned that to you. It is nothing but the deviation of the extreme colors. That is delta of, basically, you know, delta of violet minus delta of red, and this entire thing divided by delta of yellow. Now, how do you find each of these deltas? That's a very simple task, and I have just given this to all of you. Remember, delta is nothing but A into mu minus 1. So just substitute the values. A into mu, what is this? Violet minus 1 minus A into mu red minus 1 the whole thing divided by A into mu yellow minus 1. A goes everywhere and this one also goes. So you are just left with mu violet minus mu red divided by mu yellow minus 1. You can remember this formula, but if you don't remember, these are the steps to get to this formula. You can remember this formula directly from my previous slide. Now let's start putting the values. Mu violet, is mu violet given? Yes, it is given. It is 1.6. Mu red, it's 1.4. But the problem is, what is the value of mu yellow? It's not given. So remember one thing, yellow is always the mean color. It's the mean color. If it is the mean color, what does it mean? Everything is average. So even the refractive index of yellow color is refractive index of red plus refractive index of violet divided by 2. So it will be 1.6 plus 1.4 divided by 2, which is 1.5. So that 1.5 will come over here. Got it? So it's the average color. So that's how you get it. Many people did not know this trick. So 1.6 minus 1.4, that's 0.2, and this is nothing but 0.5, which is 2 by 5. Is 2 by 5 there somewhere? 2 by 5 is nothing but 0.4, guys. Yep, that's the answer. Yeah. Umesh, when you are a part of the crash course or basically the vPro, then you will get the Tattva material in the form of assignments. That's how you can download it. Okay. Jagdish, you don't have one-to-one course, bacha, for higher grades. It's only for the lower grades that you have the one-to-one correspondence. Aryan, God bless you with a speedy recovery and please take care. Drink a lot of fluids. Follow doctor's advice. Please recover, bacha. A lot of kids these days are suffering from COVID. It breaks my heart, and especially when you guys are hardly vaccinated or just vaccinated with one dose. So as soon as you get an opportunity, please get vaccinated and please stay indoors. Don't go to crowded places. Don't try to avoid exposure with other students also, because a lot of students are getting it. I know it's not very dangerous. Not many hospitalizations are recorded, but why unnecessarily get into trouble, right? So try to avoid and limit your exposure with outside world. Okay, moving on to the next one. Now we know that one prism can create dispersion, spreading of light. But what will happen if I have two prisms? That's an interesting thing. How you place them also will matter. Imagine one thing where you have a prism here and another prism here. So what will happen is, whatever light will get spread over here, it will spread even more in the next prism. Okay, I've not drawn it properly, but let's say the light spreads by some amount through the first prism. In the next prism, it will spread even more. But if the prisms are upside down, opposite, then the amount by which it spreads will again be converged by the second prism. Do you guys agree? It will again try to converge it. So here is how it looks like. Aditya Pratap Singh, this is an English medium channel. We have English, Hindi channels also in Vedantu. But for all the English medium students, we have the English medium channel out here. Okay. Anandvana PP, you cannot subscribe just for one chapter, bacha. It's for all the chapters, and think of it this way. You are getting test series for free. You are getting assignments, practice material, doubt solving. So might as well go for 8,000. 8,000 is nothing considering whatever you are getting. You guys pay lakhs of rupees for one coaching without half the things. So makes sense, right? Okay. Now this is the combination of prism where the light spreads and again converges back. But on this side, you might not get exactly what you are expecting. That's why you have two kinds of combination of prisms. One is dispersion without deviation, which is also called as the chromatic combination. Chromatic combination. What does that mean? Observe. Dispersion without a deviation. Very important. What is that key word which is important? Without deviation. Spreading is happening. Dispersion is happening. Spread means spreading of colors. So chroma, what is chroma? Chroma is nothing but color. Chroma is nothing but color. So chromatic combination, that means colors are spreading but deviation is not there. Meaning that light which is coming out from here, okay, it has some spread, the colors are different, but the average light which is going is parallel to the incident light here. This light which comes out is parallel to the incident light. That's when there is no deviation. Is that understood? Is that understood? Thank you, Umesh. Thank you, Sri Harshit, so much. PG Wolf, you are quite late. There is nothing like mini course, okay, for Crash. It's a course of 90 sessions, Anandvana PP. So, in this kind of chromatic combination, the placement of the prism is such that the average color will not have any deviation. So, the final delta will be 0, no net deviation. So, here is how I should write this down as the net deviation. The net deviation is 0 because there is no deviation. That means deviation in the first prism is the deviation in the second prism for the average color. Which is the average color? Yellow. Yellow is the average color for the mean color. Mean color. On an average, there is no net, deviation. The incident and the final rays are parallel. That's what it means. So this should be basically 0. That's what it says. So what is the deviation formula? A into mu minus 1. So A of the first prism, mu of the first prism for yellow color minus 1 is equal to, for the second prism, angle is A2, A prime, whatever you want to call it, into mu of the second prism for yellow color minus 1. So that's the condition, my warriors. Now should you remember it? Not at all. If somebody has told you, you should remember it, 100% guarantee you will get confused. A1 into mu 1 yellow, was it yellow or was it violet? I get confused. And then there is another combination, then you get more confused. So don't remember. Instead, what you should remember? This statement. Listen to it carefully. See what is not happening. Don't see what is happening. See what is not happening. What is not happening? Deviation is not happening. If deviation is not happening, that means deviation through the first prism is the deviation, counter deviation in the second prism. So delta in the first is delta in the second for the average color. If you remember that, that's it. You can write it down within 10 seconds rather than trying to recollect for 1 minute and that too in a confused manner. Understood, my warriors? This will be found in the playlist of Pathfinder. Thank you, Gayatri, so much. Okay, perfecto. Let's move on. And by the way, I have kept this formula, but you are not supposed to remember it, okay? So many books will give you this formula and they'll ask you to remember that. Okay, many institutes will also do that. Don't do that. You don't do that. Achromatic. Achromatic. Chroma is color. I have mentioned this to you. Chroma is nothing but color. So achromatic means no color. No color means spread of color is not there. White remains white. There is no spreading of colors. That's why without dispersion. Deviation, yes. Dispersion, not there. Remember what I told you? Never remember formulas. Always see what is not there, not what is there. See what is not there. Dispersion is not there. So when you have such a combination, what is happening is the dispersion, angle wise, whatever spread happened in the first is exactly equal to the convergence or the dispersion in the second prism. If it spreads by 2 degrees, in the next prism, it also converges back by 2 degrees. So it's the same thing. So delta theta in the first prism is delta theta in the second prism. That's it. And what is delta theta given by? It is just nothing but, mu violet minus mu red, but this is in the first prism, is equal to delta theta is again mu violet minus mu red, and this is again in the second prism. That's it. That's what it says. Okay, I hope this is clear. This is what you, oh sorry, I forgot that A, my bad. This into A, but this is A1 and this is nothing but A2. This is A1, this is A2, A into mu violet minus mu red, A into mu violet minus mu red for each prism. That's what you will get as the final answer as. Should you remember it? Obviously not. Just try to put it by remembering the formulas for delta theta. Del theta was mu of violet minus mu of red into angle of prism. That's it. Yep. Yes, Abhishek, I do know Walter Levin sir. He's an amazing teacher. Very cool teacher. He's my favorite too. Wave optics is already done, Pranav NT. It's there in the Pathfinder playlist. You will find it. Young's double slit experiment, diffraction, interference, and polarization. All these things are done already in this series. Okay, let's see if we can solve these two questions. An achromatic prism is made by combining prism 1 and prism 2. What are these values? Red and violets. Red and violets refractive index for each prism. Angle of prism in the first case is 10. What is the angle of prism in the next case going to be? Observe this wordings carefully. Achromatic. Achromatic, what does it mean? No color. No color. What does no color means? No dispersion. No dispersion. That's what I told you, right? If there is no dispersion, what does it mean? Delta theta, angular spread in the first prism, is angular spread in the next prism. That's right. And delta theta, what is the formula? Mu violet of the first minus mu red of the first, the whole thing into A1 will be A2 into mu violet of the second minus mu red of the second. That's what it is. Do I know these values? Maybe I do. Let's find this out. A1, the prism angle for the first one is 10 degrees. So I'll just put 10 degrees here. Violet and red's refractive index, yes, I know it for the first prism. So I'm just going to put it as 523 minus 1.515. A2, I think that's what I need to find. So I'm just going to leave it as an unknown. Violet and red, yes, I know it. 1.666. That's the violet's refractive index of the second prism. Red's refractive index is 1.650. Fair enough. So A2 will be 10 degrees into 1.523 into 1.515. 23 minus 15, that's 8. So that's going to be 0.008 divided by 1.666 minus 1.650, 66 minus 50, that's 16. So it's going to be 0.016. I know what this is. This is nothing but 10 degrees into half. 8 by 16 is half. So that's finally going to give you just 5 degrees. So A2 is 5 degrees. I think I have it over here as option A. That's it. Yep. No, it's not 10.6. It is 5. Yes, Yogananda is correct. Abhishek, I think probably made a silly mistake somewhere. Yeah, but this is correct. Now, many books give this answer as something else and they give a wrong answer. So please understand, that's why it is very important to know the correct solution. Many solutions available online, they have even written down the solutions, printed it, made video lectures with the wrong answers, with the wrong method, and that's why it's very important you get proper guidance. Many students ask me, sir, I can get all the questions online if I search it somewhere or the other. That's the problem. They have given wrong answers. Sometimes they have got the correct answers by a wrong method. That's very dangerous, very, very harmful for your scores and understanding. So that's the reason why you should learn from the proper, correct mentor, and you should ask your doubts to a proper mentor rather than searching and googling for it. Okay, so yeah, option A is correct. Moving on to the next one. All right, let's do this. MD Rameem, you're a little bit late, but maybe next time you can be on time. First of all, hit the subscribe button in case you haven't done that, my warriors. Yeah, so that you get all the lectures free of cost on YouTube. Number 2, also smash the like button so that next time the way YouTube algorithm works is it will pop up my class whenever it is coming up. So you know, yes, it is there, and in case you miss it also, it will again pop up so that you know, okay, I have to watch it as a replay. A thin prism having some angle of refraction, that is angle of prism, is made of glass. Okay, the prism combined with another prism, refractive index 1.2, the combination gives dispersion without deviation. The angle of the second prism is. Okay, observe what is not happening. Dispersion, yes, without deviation, no deviation. That means the light which bends is bent again so that deviation is not occurring. That means delta in the first prism is delta in the second prism. Delta is A into mu minus 1. This is first prism. Delta in the second prism is A into again mu minus 1. Correct? See now, put the values. Do I know the value of A? 1? Yes, it is 5. Mu 1? Yes, it is 1.6. A2? I think A2 is 1. Oh, sorry, that's mu 2. A2 is not known. Mu 2 is 1.2 minus 1. So A2's value will be 5 into 1.6 minus 1, that's 0.6. 1.2 minus 1, that's 0.2. So that will be 5 into 6 by 2 is 3. So that means it will be 15 degrees. So A2 is 15 degrees. Do I have it somewhere? Yes, option D. Correcto. The total weightage of thermal and modern physics in physics and chemistry JEE Advanced is not so much. But if you combine it with physics plus chemistry, the two with thermal and modern, then it becomes significant. At least 20 to 30 marks. 20 to 30 marks minimum. Okay. Oh my God, Ramya Lal, is that really? Which school and which city are you from? It's so good. It made my day. Thank you so much. What is the formula for the biprism is not there in the syllabus. Don't remember that, Yogananda. Okay, it's not there. Fresnel's biprism and all of that. But it's the same thing. It's deviation happening on the top surface and deviation happening on the other prism at the bottom. Okay, great. So it is 0.4. No, it's not 0.4. It's 15 degrees. Be careful. Okay, so this is your homework question. This is your first homework question. The dispersive power of the prism depends on. This is your second homework question coming up on your screen. Make sure you post the answers in the comment section. This is your third homework question, and this is your fourth homework question. Post the answers in the comment section. You will get the solution on our Telegram channel. Oh, you're from Kerala. Nice, nice. I'm so happy. It means a lot. And let's see who and all have posted the answers last lecture. Let me open this up. Okay, let me just put this on the screen over here. Okay, so if you're wondering where to find my previous lectures, just go to playlist. That's it. And if you go to playlist, you can see it right over here. KVPY and then Pathfinder, Nurture. Nurture is for 11th. Pathfinder is for 12th. So you can just click on this physics part, Pathfinder 12th, and that's it. You just go below over here, click on this icon. Okay, and you can probably minimize this, no longer needed. You can see all the lectures right from electrostatics, capacitors, electricity, magnetism, ray optics, wave optics, EM waves, everything is there. And yeah, this was lecture 3. Lecture 4 will also get added up very soon. And in case you want to see that as well, that's not that difficult. Just go to videos. There you go. Refraction at curved surface. That's it. This is the lecture. This is my last lecture. Lecture 4. Today's lecture was lecture 5. And thank you so much, Sabrish. I think Sabrish have answered this doubt as well. Can I do a Menti? Yes, I'll be doing a problem solving session, Vaishal, don't worry. Siva, very good. And Menti of ray optics. So a lot of you want some problem solving session. Yes, noted, after February 14th, definitely. Yep. Modern physics will happen after this, Yogananda. Yep. So I don't know, Selva, why they are waiting for it so much. It should have happened, right, by now. I don't know what they are waiting for. It's very irritating. It's very frustrating. As a student, as a teacher, you know, they don't even announce the dates of the term 2 exam exactly when it's going to happen. What about JEE? What about KVPI? It's like, I don't know when is it going to happen. I'm just waiting for it. And by the way, see, this is the details of the crash course. You can see 50% off is valid only now for the next few days. It will go off after 31st. But don't wait till 31st, you join it now because the classes have already started. But yes, whatever you have missed, you will get the replays of it. And just select your target exam. So it could be NDA, it could be CBSE, KVPY, whatever you want. Now the best part is when you select the when you select the JEE crash course, you get 20 test series, you get doubt solving till the last date. So your sessions might be over in March. This is very important. Many people don't know this. Unlimited doubt solving for free till the last exam date. So whenever it happens, 4th, 5th, how many ever attempts. This is very important. And there will be strategy and guidance sessions just for you, which will not happen anywhere else, only on the platform. And 10,000 is the offer price after discount, and you get more offer using my coupon code SHCC. And when you use the coupon code, you will also find me in the crash courses, plus you'll also get me not just me but other teachers as well, and plus you'll get the assignments and my support if anything goes wrong. So go ahead, join this as soon as possible, and every detail that you want about the course is mentioned over here. You can just click on buy now and that's it, it will open up. So it was amazing, guys, to meet you today and complete this amazing part of dispersion and prisms, and hopefully I'm going to see you in the JEE crash course for 2022. Make the best use of it. Usual price is 9,000 after discount, current price is 8,000. okay, this is not 9,000, it's 8,000. okay, 20% off. All right, thank you so much, take care, have a great time. Bye bye Ramya, bye bye Tinkul, bye bye Twin Gamers, bye bye Pranav. Yuganandana, I think I just mentioned I will be definitely doing modern physics after this, definitely. Okay, bye bye Tinkul, take care. Hasta la vista, this was Captain Shreyas signing off.